Hello everyone, this is your teacher MJ and I'm back for another learning episode. Together, we will explore, discover, and enjoy life through Science 8. I know that you are all excited for this week's lesson, so get ready to take off. This is DepEd TV. Last week, we learned about forces, its types, examples, and how these forces are combined. Did you enjoy last week's lesson? I hope you did. And I hope that you will also enjoy our lesson this week because it is connected to our previous lesson. It is all about Newton's 3 laws of motion. With no further ado, intayon! Before we proceed, let's see how far you know about our new lesson through a pre-test. Try to answer these questions. If you get a wrong answer, don't worry. You'll get to understand it better after our lesson. Who formulated the 3 laws of motion? A. Aristotle. B. Isaac Newton. C. Thomas Edison. Or D. Alexander Graham Bell. The correct answer is B. Isaac Newton. Which has more mass? A kilogram of cotton or a kilogram of iron? A. The iron. B. The cotton. C. They both have the same mass. Or D. Cannot be determined from the given information. The correct answer is C. They have the same mass. It is the tendency of an object to maintain its state of rest or of uniform velocity in a straight line. A. Acceleration. B. Inertia. C. Interaction. Or D. Motion. The correct answer is B. Inertia. Which has the greatest inertia? A. Airplane. B. Car. C. Jeepney. Or D. Bike. The correct answer is A. Airplane. Which of these vehicles moving at the same velocity is difficult to stop? A. A bus. B. A car. C. A train. Or D. A truck. The correct answer is C. A train. All of the following apply the 3rd law of motion except A. Staring at a painting. B. Rowing a banca. C. Throwing a stone. Or D. Taking out ketchup from a bottle. The correct answer is A. Staring at a painting. Which Newton's law explains when a man is pushed forward in the car as it stops? A. First law. B. Second law. C. Third law. Or D. Second and third laws. The correct answer is A. First law. A boy jumps out of the boat into a dock. As the boy moves forward to the dock, the boat moves backward. Which statement describes this situation? A. An object at rest remains at rest. B. Friction opposes the motion of an object. C. For every action, there is an equal and opposite reaction. Or D. The net force is directly proportional to mass and inversely proportional to acceleration. The correct answer is C. For every action, there is an equal and opposite reaction. Look around you. What can you say about the things you see? What can you say about the vehicles moving and the people walking? Have you ever wondered what causes their movements? What if there's no motion at all? Motion is referred to as an object's change in position upon application of force by another object. If there is an unbalanced force, it is expected that the object which the force has acted upon will be in motion. Let us start today's discussion with an activity. Your task is to locate the given words in the grid. The words appear horizontally, diagonally, and vertically. I know you can do this. Let's go! Acceleration. Action. Aristotle. At rest. Buridan. Equal. Force. Galileo. Inertia. Interaction. Mass. Motion. Newton. Peloponnes. Reaction. That was fun, wasn't it? We're going to discuss these words later on. For now, let us try to understand the timeline of the significant development of the concepts of force and motion. Motion has been studied for centuries by many great minds. Aristotle, for example, believed that a moving object needs a continuous application of force to keep it moving. To him, an object is naturally at rest. He believed that the greater the force on the object, the greater is its speed. He introduced the idea of impetus that keeps a body in motion. John Philoponus conceptualized the idea of surrounding force similar to inertia found in Galileo's idea and Newton's first law of motion. He first introduced theory of impetus, a concept similar to force. According to the theory, when impetus decreases, the speed of the object also decreases. When that impetus is removed, the object stops moving. John Buridan also saw impetus as the cause of movement. He further developed the theory of impetus introduced by Philoponus. According to him, motion is possible through a mover that keeps the object moving with power proportional to the speed and mass of the object. When the mover is removed, the object stops moving. He later named impetus as force. Galileo Galilei, on the other hand, disagreed with Aristotle's claim. He claimed that even without continuous application of force, an object can continue to move with constant speed in a straight line, provided that there are no outside forces acting on it. Finally, Sir Isaac Newton used Galileo's ideas and eventually formulated the three laws of motion. Who is Sir Isaac Newton? Sir Isaac Newton is an English mathematician and physicist born on January 4, 1943 in the United Kingdom. He is one of the most popular and influential scientists in the world, notable for his works and discoveries such as the laws of motion. Now that we are familiar with the people behind the discovery of how force and motion could be explained, let us have a deeper understanding of these. We all have been taught that science is a systematized body of knowledge based on facts acquired through careful experimentation and observation. Many phenomena, including force and motion, can be explained by actual observation and simple common sense. One of the famous individuals who developed an explanation for motion, which lasted for almost 2,000 years, was the Greek philosopher Aristotle, who developed the idea that in order for an object to move, force must act upon it. But when that force is removed, the object comes to rest. Another important person to remember is Galileo Galilei. In his experiment, he let a perfectly round ball roll down an inclined surface and prepared 3 setups under ideal conditions. This means that there are no friction and air resistance. After doing this experiment, these were his observations. In the first setup, the ball is released at a certain height. It speeds up, and if it rolls up another inclined surface of the same slope, it slows down and reaches the same height. In the second setup, the ball is released from the same height as the first setup. It speeds up, and if it is rolling up another inclined surface that is not as steep as the first setup, it slows down and reaches the same height. However, it covers a farther distance as it rolls up the slope. In the last setup, the ball is released from the same height as the second setup. This time, it continues to roll in a flat surface. The ball does not speed up nor slow down as if it continues to move forever. After his experiment, Galileo Galilei came to the conclusion that in the absence of friction and air resistance, the ball would continue rolling up to a height above the base equal to the height from where it was released. On a flat surface, The ball would continue to move forever, since there will be no force to cause its state of motion to change. He was the first to suggest that uniform speed straight line motion was just as natural as at rest state of motion. He called this tendency of an object to maintain its initial state of motion as inertia. Although Galileo Galilei did not fully explain motion, he took the first important step that completely changed the world's view about motion of objects. Sir Isaac Newton's three laws of motion established the relationship of an object's motion to the forces that act upon it. The law of inertia, the law of acceleration, and the law of interaction. Newton's first law of motion is the law of inertia. States that an object in motion will continue to move at constant velocity, and an object at rest remains at rest unless acted upon by a net force. What is inertia, by the way? When we say inertia, we refer to the tendency of an object to maintain its state of rest or of uniform velocity in a straight line. To understand inertia, let's go back to one of the questions in the pretest earlier. Which has the greatest inertia? Airplane, car, jeepney, or bike? The correct answer for this is airplane. Why is it so? That is because mass is a measure of the inertia of an object. This means that the greater the mass of an object, the harder it is to move when it is at rest, or difficult to stop when in motion. Obviously, among the given choices, airplane has the greatest mass. Thus, it is harder to make it move or stop. This is also one of the reasons why airports have long runways for airplanes to take off from and land to. The heavier the plane, the longer runway is needed for it to produce the speed it needs to take off or reduce it to stop. Now, to understand the law of inertia, take a look at this video. Look closely. What can we observe and conclude from the video? Great! When the car starts to move, your body also moves backward. Also, when it stops, your body moves forward. You may not see or observe, but your body resists movement as the car starts to move and as it stops. However, due to unbalanced forces, your body can't resist movement. Thus, it moves. That is all for today, Sci folks. We will continue our discussion tomorrow. Indeed, learning is fun as we explore, discover, and enjoy life through science. Again, this is your teacher MJ, and this is DepEd TV. Keep safe, everyone. See you tomorrow.